So there are some of you that still owe me some of the stuff off Schoology that's still open. Some of you have the derivatives quiz in which you can use the notes from that page. You can come do that. So please let's make sure that's getting made up. I am on 5.1 in the notes. We had started this the other day, but it's kind of a bigger idea, so we didn't get real far with it. So we really just kind of recap what we had talked about. All right. So let's kind of just briefly go over some of the things that we had talked about the other day. So we had a graph that looked like this. Okay, there's definitely some characteristics about the graph that are important to us. So if this is just some sort of mathematical function drawn, we don't have to know what the actual equation is. We can just look at the graph. So some of the things that are important to us, that point, this point, and this point, the blue, those are our critical values. And a critical value is a max, a min, or a point of inflection. So again, I'm just kind of recapping a few things. So a max, min, or a point of inflection. And then we also know this green would be where we are increasing. Okay, if I took the derivative at that point would have a positive slope. This point right here would be decreasing because basically if we took the derivative or if we just looked at it, we'd have a slope of our tangent line would be negative. So that's the ins and outs, what we've worked on. And then down below it said we wanted to draw that F prime chart. Okay, so I might just kind of do this. What's kind of nice, and you can always do this if you want to just draw a line right below it. I'm going to incorporate this, and this. So what I'm doing is our local max, min, or point of inflection are that. So if we were to talk about, okay, I know the slope over here is negative, the slope in between here is positive, hits a point of inflection, still stays with a positive slope, and goes negative. Okay, so that's what our F prime, our first derivative chart looks like. Okay, and again, it makes it nice if yes, I realize sometimes it's like, here's this here's this picture, and then over here, here's this graph. Well, just draw the line underneath it and just link those critical points to it. So it talked about down below, you had a graph that looks something like this. Okay, there might not be an arrow at the end, and that's okay. But then they have over to the side. So they tell you that, hey, this is A, this is B, and this is C. So the important thing to do is you label your A, B, and C on your line, and you look at it and say, okay, here, this looks like it would be a positive slope. Between here, this looks like it would be a negative slope. And then on point C, and I didn't do it as nicely. So this right here has a positive slope, and then here also has a positive slope. So the positives and negatives, this is just referring to the slope of the tangent lines, whether it's a positive slope or a negative slope. Exactly at those points, the slope is 0 because that makes a horizontal line, and a horizontal line has a 0 slope to it. Okay, so that was the first part of the 5.1 notes, going through it. Okay, we okay so far? Now I'm on the back side of the 5.1. This is called sarcasm, my friends. Notice I'm sitting here looking at my phone, not paying attention to you. Please be respectful of the class. Some of you are so addicted to your social media, it's taken away from your education, and it saddens me. You're making billionaires richer. It saddens me. Okay. So I'm on the back side of the 5-1 notes, and they give this. And they have this. Okay? That's all they give us. So to the left of 1, we would have a slope that's positive. Between 1 and 3, we have a negative slope. At 3, it's probably a point of inflection. The reason I know it's a point of inflection because it goes negative, negative. It's the same sign. From the left side of 1 to the right of it, I go from a positive to a negative. So that means at 1, we have a local maximum. We have a maximum point. The graph comes up and then comes back down. At the point 5, because it was coming down, we have a slope coming down, and then it turns to go up. So that's a local minimum. That's our point of inflection. So this graph actually gives us a lot more information, as vague as it is. Okay? So I'm just going to put, this would have been a maximum point. This would have been a point of inflection, meaning it flattened out, but still continued in the direction. And this would have been a minimum point. Okay? So we want to draw what we think the graph would look like. Okay? So values that I would probably put on my graph is I'd put 1, 3, and 5. Okay? Now, I don't know exactly what this graph is going to look like, but I can get a general idea. I don't know where it's necessarily crossing the x-axis or the y-axis, but I have a general idea. And there's a lot of different iterations to this to watch. So right here, we have kind of a positive direction we're going. Okay, and then here, it goes negative, something like this, and then it goes negative again. And then it starts going positive. Okay, this is what it kind of could look like. Okay, the slope here is positive, the slope here is negative, the slope right here is 0, the slope here is negative, and then the slope here is positive. Okay, this is kind of a visual representation of what it could look like. I can't guarantee it looks exactly like that, but this graph conveys exactly the things we want. Okay, we looked at the F prime chart. They told us, they said, hey, this is F prime. What does F of x look like? Okay, so I said what F of x looks like and things that ever took place. So if you go from a sign change from a positive to a negative, it's a max. If it goes negative to a positive, it's a min. Okay, if it's the sign doesn't change, it means a point of inflection took place between the two. All right, so that's example 1 on the back side of the 5-1 notes. Okay. Example 2 looks a little different, but it's the same type of characteristics. This one goes negative, positive, 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 negative. Okay, so there's definitely a point of inflection. How can I guarantee there's a point of inflection on that F prime chart? What sticks out that says a point of inflection versus a max or a min? Same side twice in a row. And it doesn't matter if it's positive, positive, negative, negative. Very good. Okay, so this one, they gave us -3, 1, 4. We have negative, positive, positive, negative. Friends, where's my point of inflection guaranteed? 1. That's point of inflection. So if I go positive slope means the line's doing this, to negative slope, Where do my fingers meet? A max or a min? Max. Okay, so we have a max here. And then negative, oh shoot. Negative to negative, where do my fingers meet? A max or a min? Or a negative, excuse me, a negative to a positive. It's a min. Okay, so this is a min. So again, we could draw our graph of f at x and give a general idea. Let's list our important points. So I get negative 3, 1, and 4. So to the left of negative 3, we have it's coming down. Okay, and then it goes positive. And right there, it flattens out, and then it continues positive. And then we get to 4, and it's going to start coming back down. Okay, so this should be our max, like we said. This right here has a slope of 0, so it's a point of inflection because the signs didn't change. It stayed positive, positive. And this is our min. Okay, again, that's relatively what our picture would look like of if we knew the derivative sign chart. Is this okay? So a max is a high point, a min is a low point, a point of inflection is where our graph would flatten out and then continue in the same direction, whether it was positive, flatten out to 0 and then go positive, or negative, flatten out and go to 0 and then negative. Okay, so those are just some different ideas that come along with it. Okay, so they want us to graph this function. And there's definitely some things that we can look at on this function. I could think about the roots. And that would be where x to the third minus 12x is equal to 0. And you could use Desmos on this, or you could say, oh, I kind of sort of remember I have a greatest common factor I could factor out. This would tell me that x is equal to 0, and then I have x squared minus 12 equals 0. Add 12 to both sides. And then root. And if we do the square root of both sides, we have to remember what key feature. Plus or minus, thank you. Okay, so all of these are roots, meaning 0, 0 is a root. Root 12 comma 0 is a root, and negative root 12 comma 0 is a root. And what tells you that it's a root is the y component is 0. Okay, so if we looked at a graph, I know that I'm going to have, I'll just keep these, let's change the graph. I'm going to change this color. Get a little neater. Let's change this to green. And so I know roots are taking place here. Negative root 12 and positive root 12. And think about it, root 12 is about 3, between 3 and 4. Okay, so I don't necessarily have to have other things labeled on the number line on that. So that's the first part of our graph, and then we have 0. So we have the roots that are there. Now, what makes this different is knowing the roots is where can we see if this is increasing or decreasing? All right, well, let's do f prime of x. F prime of x means I'm doing what to it? Derivative. So the derivative of x to the third is 3x squared. Derivative of negative 12x is? Okay. Are you okay with that? Okay. So, in order to find the roots, the original is equal to 0. Still with me? And then you're using algebra. Of course, use Desmos. You can graph it. You can see the same thing. Now, unfortunately, on Desmos, it's not going to give you negative root 12 and positive root 12. It's going to give you 3 point something and negative 3 point something. That's okay. Okay, it's not going to bother me to know that. But the justification of certain things might be known. So there's one thing I want to do with the derivative. So notice, in order to find the roots, I set equal to 0. Could I set my derivative equal to 0? could I set my derivative equal to 0? And if I set my derivative equal to 0, I would know max, min, or point of inflection. Okay, it's one of those three. Okay, so let's do that. So let's take this. I'll go 3x squared minus 12 equals 0. Add 12 to both sides, just algebra 1. Divide by 3. Take the square root of both sides. Don't forget the what? Plus or minus. So at plus or minus 2, there's something that's going to take place. It's going to be a max, it's going to be a min, or it's going to be a point of inflection. Okay, so now we have to, now let's pretend decimals and graphing calculators and t-tables don't exist. Actually, a t-table would be okay. So let's pick a point. So that's all of our important information. I set the original equal to 0 to determine roots. I set the derivative equal to 0 to determine max, min, or point of inflection, which are called critical values. Okay? So let's pick a point way out here. Would you feel comfortable saying that negative 10 is way out there? Anyone like, where are you getting negative 10? I'm picking something far to the left. Okay, and then I'm going to pick a point over here. Let's pick 10. Do you feel comfortable knowing that negative 10 and positive 10 are outside of our roots, are outside of our critical values? Okay, I don't know which one's a max, which one's a min, which one is a point of inflection. I do know where it crosses the x-axis as our roots. We had found that with the red dots. So let's pick negative 10. Negative 10, let's plug in. Negative 10 times negative 10 times negative 10 is a negative 1,000. Agree? You follow me on that math? Negative 1,000, negative 12 times negative 10 is positive 120. Negative 1,000 plus 120. Is it still negative? Okay. So that means this is going to give me negative in the y direction. Means it's underneath the x-axis. Okay. Let's pick positive 10. 10 times 10 times 10. 1,000. 1,000 minus negative 12 times 10. So 1,000 minus 120, is it a positive number? Okay, and we don't have to know the exact value. We just need to know, hey, something's taking place at either place. So we have some end behavior ideas that are taking place. Way to the left, it's negative. Way to the right, it's positive. Something's going to happen in the middle. Okay, so maxes, mins, and point of inflection are what? What's the slope at each of those? Maxes, mins, and point of inflection. What is the slope exactly at points of inflection, max and mins? 0. Okay. So things that I would probably know so far about this graph is I would know this so far, guaranteed. It's going to look something like this. Okay. Over here, I know it's going to look something like this. Okay. Now, I might have the pitch of the line incorrect, but I'm pretty confident that my picture is going to look like that. Now, there's something that's going to happen between negative 12 and positive 12 because we have two critical values. The critical values it's the derivative where the derivative is equal to 0. At negative 2 and at positive 2, there's a critical value. There is a turning point. It's a point where the slope at that exact point was equal to 0. So it could be a maximum, could be a minimum, or it could be a point of inflection. What do you think the slope of this green line is, roughly? Positive, negative? Positive? What about the slope of this line? Is it also positive? it's heading to the upper right is what it is doing. Okay? So now, we know that we have a positive at either end. So our sign line, let's do this. Oops, go away. I knew that was going to happen. So right now I know I have a positive over here. Let's do that in black. And I have a positive over here. That's just our slope of our tangent line. Okay? Some other values we need to know. It's okay that we have the 0. It's okay that we have the -2. Oops, I don't know why I put square root -2. Sorry about that. And I know I have +2. Okay. So up until -√12, something's going to take place. At this -2, a few things are going to happen. So let's see. -12, -√12 is -3 point something. -2 is just -2. So if I were to take -3 would fall in between the -√12 and the -2. Agree? So let's think about, if I go -3 times -3 times -3, I get -3, -3. Positive or negative? Negative. So -27. This becomes a positive 36. -27 plus 36 is? It's a positive number, right? I have 36 bucks in my pocket. I buy something that costs $27. I still have some money in my pocket. Okay, so that means it's above. So our line's going to kind of continue a little bit above here. Okay, but something's going to happen at -2. Okay, but we're not sure what is going to take place yet. Okay, I'm just going to flatten this out a little bit at the -2. All right, something's going to happen between 0 and -2. So if I take -1 and plug it in, -1 times -1 times -1 is -1. -12 times -1 is +12. -1 plus 12, is it positive or negative? Positive. So that's going to verify. That's going to come back right down there. And it was a root, so it's going to come back down here. Okay? If I take 1 and plug it in, if I plug 1 in here, because 1 is between 0 and 2, 1 times 1 times 1 is 1. -12 times 1 is -12. 1 minus 12, positive or negative? Negative, so it's going to be underneath. At that 2, I know what this graph is going to look like. Okay, so my max at my min, I have a slope of 0 at both. Was there a point of inflection that took place here? No. Could there have been? Yes. Okay, so things to know. This region here, go to black, had a positive slope. This region here also had a positive slope. This region in between them this region right here had a negative slope. So our sign line comes out pretty nicely, where we have positive here, negative here. These are our major values, and then we get positive over here. So we definitely, the positive's taking place here. That's all positive. Positive's taking place here. That's all positive. Negative takes place in between, meaning the slope of the tangent line would be negative at that point. It's decreasing at certain regions. It's increasing. Okay, so there's kind of a lot that we hit upon this, and sometimes it gets goofy to kind of fathom. All right, so what I want to do is this. Let's make sure let's do worksheet 5.1. Let's do 1 through 7 odd. Okay, try it. Okay, you should do okay. I actually have to modify my thing. I'm going to have to awkwardly stand between you guys. That's okay. Don't need